Okay, good morning, Mr. Korean, Mr. Christopher Andreas. So in this video, we are going to explain about 1 and 2 sample tests of hypothesis.
My name is Felicia Tiffany.
And my name is Edwin Caroldo, and we're going to start the video. Yes. Okay, so why is hypothesis testing is important? Okay, just imagine you're in the kitchen and you're about to try a new brownies recipe, and you're not sure if the amount of sugar is just right. So do you trust your guts, or do you get a feedback from other tasters? This is an example of hypothesis testing and decisions instead of relying on our gut feelings.
So now I will explain to you about 6-step process. There are 6 steps to answer the hypothesis example. The first one is step 1 is hypothesis. State the null hypothesis and state the alternate hypothesis. The first one is if the null hypothesis mu is equal value, so the alternate hypothesis is mu unequal value. The next is if the null hypothesis is mu greater than equal value, so the alternate hypothesis will be mu less than value.
So both of the value must be different and vice versa.
And the last one is if the null hypothesis is smaller than equal value, the alternate hypothesis will be mu larger than the value. And the step 2 is declare the alpha from the description in the example, in the question. And the step 3 is select the test statistic. Either it's t-test or z-test. And the step 4 is formulate a decision rule. This is the example. Formulate a decision rule. Reject null hypothesis if C calculate greater than C table. And step 5 is make a decision. If we use it as, so we have to calculate with this formula. It's C equal with X bar min mu per population standard deviation per square root of n. If t test X bar min mu per standard deviation per square root of n. And the last step is interpret the result. This is the example. This is fail to reject the null hypothesis.
Have we started the recording yet, Feli? Okay. Sorry, Mr. Sorry, sir. We forgot to explain this. Okay, so there are 3 types of tails. So when the null hypothesis is equals to the value and the alternate hypothesis mu is not equal to value, so we have to use 2 tail. Well, this one we're going to use left tail when the null hypothesis mu is greater equal than the value. We use the left tail, and then we use the right tail when the null hypothesis of mu is less equals than the value. Yes. Okay, so the first question. A manufacturer claims that the average lifespan of a light bulb is 1,200 hours with a known population standard deviation of 100 hours. A quality control inspector randomly selects a sample of 50 light bulbs and finds that the average lifespan of the sample is 1,150 hours. At a significance level of 0.01, conduct a one-sample hypothesis test to determine if there is sufficient evidence to support the claim that the average lifespan of the light bulb is less than 1,200 hours. Okay, do you guys remember the first step out of the 6 hypothesis steps that Phil explained before? We need to clear the hypothesis. So the null hypothesis mu is greater equal than 1,200, while the alternate hypothesis mu is less than 1,200. This means that we're going to use 1 tail. And the second step is the alpha. We can see that the alpha is 0.01 from the question before. The third step is we need to choose between two options, which is z-test versus t-test. Since the population standard deviation is known and the sample size is pretty large, so the S is 4 and the number of samples is 50, the x-bar is 1150 and the mu is 1200, and we also know the standard deviation is 100. So we use this formula. Z equals to x bar minus mu divided by standard deviation divided by square root of number of samples. And the fourth step, so for one-tailed test at a significance level of 0.01, we look up the critical z value from the z table. We know the alpha is 0.01, so the z is negative 2.33. So we reject the null hypothesis if z is less than negative 2.53. And this is a left one-tailed test, and the negative 2.53 is 0. Okay, the fifth step is we just have to put the numbers in this formula. So the x bar is 1150 minus by the mu, which is 1200, divided by the standard deviation, which is 100, divided by the square root of the number of samples, which is 50, and we got negative 3.54 here. So negative 3.54 is smaller than negative 2.53. And the last step 6, since negative 3.54 is less than negative 2.33, so we reject the null hypothesis. There is sufficient evidence to support the claim that the average lifespan of a light bulb is less than 1,200 hours. Thank you.
Next, we are at the example number 2. Suppose a researcher wants to test the average height of a single plant species is different from 50 centimeters. But the researcher has no time to test all of the height of all that plants. So the researcher thinks and has an idea. The idea is the researcher takes a sample of 15 plants and finds a sample mean height of 52 centimeters with a sample standard deviation of 4 centimeters. At a significance level of 0.05, conduct a one-sample hypothesis test to determine if there is sufficient evidence to conclude that the average height is different from 50 centimeters. The first step is hypothesis. The null hypothesis is mu equal 50. The alternate hypothesis is mu unequal 50. So that is mean is 2-tailed. And the step 2 is alpha. The alpha is 0.05. The step 3, we use t-test or c-test, and we choose t-test because the standard deviation population is unknown and the sample size is relatively small. This is the formula of t-test, and the standard deviation is 4, the sample is 15, the x-bar is 52, the mu is 50, and the degrees of freedom is n min 1 equals 15 min 1 equals 14. And in step 4, we reject null hypothesis if t less than min 2.145 and t greater than 2.145. The step 5 is count with this formula. So the x bar is 52, the mu is 50 per standard deviation is 4 divided by square root of n, and the n is 15. So it's the value is 1.93, and 1.93 is smaller than 2.415 and greater than minus 2.415. So since the 1.694 less than 2.415, we fail to reject the null hypothesis, indicating insufficient evidence to conclude that the average height is different from 50 centimeters.
Now we're heading to the two-sample test of hypothesis. The goal here is to compare the means of two independent samples to see if they are significantly different from each other.
There are 3 types of cases. The first one is independent samples. there are one event, standard deviation calculation are known, standard deviation are equal. So we use C-test for this because the standard deviation calculation are known. The second one is independent samples. One event, standard deviation population are unknown and the standard deviation are equal. So we use T-test for this one. And the last one is dependent samples. So only one event, two dependent samples. So we use T-test. Next one.
Okay, so there are three types of cases. This is the formula when two means are known. And this long formula is for the t-test and the pool variance. So two sample test of means and unknown but equal standard deviation. And this is the pair t-test, this is the formula. And this is the formula of the two samples test of means, unknown and unequal standard deviation. This is the T formula and the degree of freedom. Okay, back with me again. Number 3. A sports analyst is interested in comparing the free throw shooting percentage of two different basketball teams during the season. Sample 1, Team A, 40 players with a mean free throw percentage of 75% and a population standard deviation of 5. Sample 2, Team B, 35 players with a mean free throw percentage of 80 and a population standard deviation of 6. At a significance level of 0.05, can the analyst conclude that there is a significant difference in the mean free throw percentages between Team A and Team B? Okay, so remember do you guys still remember the 6 steps before? We need to declare the hypothesis. So the null hypothesis of mu Team A is equal to mu Team B, and the alternate hypothesis is mu Team A is not equal to mu Team B. And because of this case, we are going to use two-tailed. And the second step is we need to find the alpha, and we know the alpha is 0.05 from the question before. So, which formula are you going to use based on my explanation before? Ta-da! This is the answer. Z-test. Why? Because the standard deviation population is known. Okay, the number of samples of Team A is 40, the number of samples of Team B is 35, and the standard deviation of Team A is 5, the standard deviation of Team B is 6, and the mean of A is 75, and the mean of B is 80. So the Z is positive and negative of 1.96. So, since we're going to use two-tailed test, so the left part of the two-tailed test is negative 0.96 and the right part is the positive side. So we're going to reject the null hypothesis if Z is less than negative 1.96 and Z is greater than 1.96. Okay, step 5. Just input the numbers into this formula. Okay, so the x bar of Team A is 75 and the x bar of Team B is 80. So 75 minus 80 divided by square root of standard deviation Team A to the power of 2 divided by the number of samples of Team A plus standard deviation of Team B to the power of 2 divided by number of samples Team B, which is 35. And we got negative 3.89. This means that negative 3.89 is smaller than 1.96. So, just conclude the whole thing. Since negative 3.89 is smaller than negative 1.96, we are going to reject the null hypothesis. There is sufficient evidence to conclude that there is a significant difference in the mean free throw percentage between Team A and Team B.
So now we're on number 4. Suppose a researcher wants to compare the average scores of two different teaching methods. They take two independent samples. Sample 1 is method A, has 10 students with a mean score of 78 and a standard deviation of 10. And the second sample is method B, 12 students with a mean score of 85 and a standard deviation of 12. Add a significance level of 0.05 and assume that the variance is unequal. Conduct a two-sample hypothesis test to determine if there is sufficient evidence to suggest a significant difference in the mean test scores between the two teaching methods. So this is the class A and this is the class 2. So the first step is declare the hypothesis. The null hypothesis is mu1 equal than mu2. There is no difference in math. The alternate hypothesis is mu1 unequal mu2. There is a difference in math. So this is two-tailed because this one. And the step 2 is alpha. Alpha is 0.05 based on that question. Step 3, we use t-test. Because the standard deviation population is unknown and the sample size is relatively small because it's only 10 and 12. The sample A is only 10, the sample B is 12, the standard deviation A is 10, the standard deviation B is 12. The x-bar of A is 78 and the x-bar of B is 85. The variance is unequal, so we use t-test. This is the degree of freedom if we use t-test. So we have to calculate the standard deviation per sample plus second standard deviation per sample, and then we square them, and per standard deviation 1 square per the first n and we square and then per n minus 1, so we get 9 and this plus standard deviation of the second, and then we square them, divide by and the second n, and we square them again, and per n2 minus 1, so we get 11. So the degree of freedom is 20. So the alpha is 0.05 and the degree of freedom is 20. So the t, we get this from the table. The step 4 is reject null hypothesis if t less than minus 2.8086 and t is greater than 2.086, and this is the area. So in right and left. The next, the step 5 is we calculate the t with this formula. So the x bar 1 is 78 minus x bar 2 85 per square root of standard deviation. The square of first standard deviation per the first n plus square of the second standard deviation per the second n. So we get 10, 10 and 12, 12 equals minus 1.49, and 1.49 is in between of 2.86 and minus 2.86. So the step 6 is we failed to reject the null hypothesis. We conclude that there is not enough evidence to suggest a significant difference in the mean test scores between the two teaching methods.
Again, number 5. A school wants to evaluate the effectiveness of a new study program on students' test scores. They measured the test scores of 10 students before and after participating in the program. At a significance level of 0.05 and assume that the variance is unequal, conduct a two-sample hypothesis test to determine if there is sufficient evidence to conclude that the study program significantly improve the students' test scores?
So the step 1 is hypothesis. The null hypothesis is mu equals 0, and the alternate hypothesis is mu unequal 0. So what we use?
Two-tile test.
And the step 2 is alpha. The alpha is 0.05 again. What? So
Which formula are we going to use? Ding 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 ding. I'm going to choose Z or T. I think T. Is it correct, Kelly?
correct, because the standard deviation population is unknown and the sample size in this question is relatively small and dependent sample. So step 4. Reject the null hypothesis if T less than minus 2.262 and T greater than 2.262. We get the degree of freedom is n minus 1. It equals 10 minus 1 and equals 9. And we get this. This is the to tell the right and left. Now, we have to count the difference. The difference is the after minus before. Like 85 minus 70 is 15. And then we sum this all and divide by n. What is n?
Number of sample, Kelly.
And we can get this 11.5.
There is a villain, guys. We have to retake our video because of this guy. Hello, Patri. Pak Chris.
After we get the D bar is 11.5. So, and then we calculate D min D bar. For example, is 15 minus 11.5, and we get this 3.5. After that, we square this column into this column, and then we sum this all to calculate the standard deviation. This is the formula. The formula is square root of square D min D bar per the amount of samples minus 1. So we can get this square root of 304.5 per 10 minus 1. So we can get this 5.81.
Okay, the fifth step is we use the T formula. So difference divided by the standard deviation divided by the square root of number of samples. So this means that 11.5 divided by 5.81 divided by square root of 10. And we got 6.259. So 6.25 is greater than 2.262. So this means that we are going to reject the null hypothesis, since there is sufficient evidence to conclude that the study program significantly improved the students' test scores. Oh iya, lupa thank you.
Thank you.
Thank you.